This is Group 5A's video lab report for Physics 273 with
Eli Keller,
Catherine Rojek,
and Nathan Seiler.
For our lab report, our objective was to confirm the kinetic equation in relation to gravitational energy. For this, we knew that the kinetic energy equation was 1/2 mass times velocity squared, and the equation for gravitational energy is mass times gravitational constant times height. Our hypothesis for this was that kinetic energy was going to equal gravitational energy, and in other words, mass times gravitational constant times height equals 1/2 mass times velocity squared. After doing the experiment, we found this to be true, as our measured velocities completed the equation and proved the total kinetic energy to equal the total potential energy. For the models in our experiment, we drew energy pie charts on the right because Newton's second law says that within a closed system, all energy is conserved. So knowing this law, the kinetic energy the moment the ball hits the ground should be equal to the gravitational potential energy before we drop the ball. And as you can see on the right, we have energy pie charts showing this and the change from gravitational energy to kinetic energy. And on the left, we also have the picture of us participating in doing the experiment and dropping the ball.
Next, I'm going to explain our experimental design. We videotaped ourselves dropping 2 balls of different masses from 2 different heights, 1 meter and 2 meter. The 2 balls were of different weights. One was a golf ball and one was a bouncy ball, which was heavier. We used the tracker on the videos to get the final velocity of the balls. We compared the theoretical energy, which is the gravitational energy, to the observed energy, EK. Using the observations of the data, we related the collected velocity to the equation. To collect data, we took the final velocities from tracker and used them to calculate the kinetic energy using the equation EK equals 1/2 mv squared. A photo of the final velocity is shown on the right. We then compared the EK to the gravitational potential energy using the equation EG equals gmh. A photo of our data collected is shown below. Trial 1 and 5 use the same setup, and we use them to test for error in tracker. We did not find the percentage error significant enough to do more than one trial for each setup.
For our scientific reasoning, we said that objects dropped from the same height all reach the same velocity when they hit the ground regardless of their masses because of the acceleration caused by Earth's gravity. Before being dropped, the object has 100% gravitational potential energy and 100% kinetic energy the moment it hits the ground. So according to Newton's second law, the amount of energy before and after the drop should be the same. So all of the potential energy in the beginning should be transferred into kinetic by the end. To show this, we used the expected velocity, which we got from using the MGH equation and then converting that into kinetic energy. And that would be our theoretical velocity. And then our observed velocity was the velocity calculated by tracker. And we found out that in trial 2 we had a percent error of 1.65%. And then we found that the possible sources of error could be a misuse of tracker with clicking the bottom of the ball inconsistently, and that would account for different final velocities. And then human error with dropping the balls with maybe not dropping the balls from the exact same height every single time, which would result in a difference in the final velocities.